Now again, if these were light bulbs which were sampled from 3 separate brands, all costing the same amount per light bulb, which one would we choose and why? Well, if we're looking at consistency, you might be able to visually say, hey, brand Y is the best option. Because you know you're always going to get 3 months out of these bulbs. With X, it's kind of hit or miss. You might have a couple duds, but you might have one that lasts as long as 8 months. Finally, brand Z doesn't have as much variability, but it is over the board from 2 to 4. Okay? You could calculate the range, which looks at high minus low, or says it extends from 2 to 4. The range in brand Y says they're all 3s, and the range here would extend from 0 to 8, or some people will take the difference, 8 minus 0, say there's a range of 8. So that's also valuable as well, which is not listed on the board at this time. But the standard deviation is one of the ideas that I'd like to get across to you, and sometimes students have a difficult time with it. All standard deviation is a measure of spread or variability. It says how far apart are you away from the average on average. So it's the average difference among all the values. Now this one, I would assume the standard deviation is 0, because there's no variability in brand Y at all. But which one do you think has more variability between X and Z? Take a moment and think about that. Let's say we wanted to take a look at the variability or standard deviation of brand X. Remember, the values were 0, 0, 3, 4, and 8, so this is the longevity of the bulbs in months. Well, the first thing you would do is take a look at this wonderful formula, which is how calculators and Minitab and Excel, SAS, SPSS as software packages utilize this idea. This is the sample standard deviation. Notice it involves a square root, there's a square of the differences, and there's a sample size of n with an adjustment of 1 for small samples. Well, let's take a look at how it's done. First of all, if you look at the order of operations, the first thing you would do is parentheses. So I make a separate column here. We're going to do one of these by hand to let you see how it's done. First thing, we knew what the average was in this sample. It was 3. So if we take each observation, 0 minus 3, what's 0 minus 3? Negative 3. 0 minus 3, negative 3. So we continue to subtract off the average in every case. So I take 3 minus 3 is 0, 4 minus 3 is 1, 8 minus 3 is 5. So you can tell these are causing some variability. This one had none, because it was the same as the mean. Now the second step is to square all the values. A statistician likes to make values positive when at all possible. So I make another column here just to show you how it's done. And we square every value. So what is negative 3 times itself? Negative 3 squared is 9. Negative 3 squared is 9. 0 squared is 0. 1 squared is 1. And 5 squared is 25. Now if you want to make sure you're doing this right, if you take this x minus x bar, that is, remember, this observation minus each mean, this should come out to 0. If it doesn't, you probably made an arithmetic error. Minus 6 and 6 is 0, so we're in good shape there. Now, we've completed much of this top of the formula, the numerator, but there's a symbol here, a Greek letter, for the sum, or the summation. So let's put in some of the parts. We now have S equals, we can do a few things. We first have to find the total, because that means the sum of all of those differences squared. So if we go ahead and do that, 18 and 1 is 19, plus 25 is 44. Does that look good? All right, so we can put in the top as 44, the sum of those differences squared. For those of you taking notes on this, and I'd encourage it, that's the sum of the deviations squared. That's 44. Now, we've done the tough part. On the bottom, we look at the number in the sample. In our case, we had 5 minus 1 is 4. So this one works out fairly well. We could be using something a little bit more sophisticated or with a little bit more detail, but in our case, standard deviation, for illustration purposes, 44 divided by 4 is 11. Now 11 is considered to be the variance in this case. The number inside square root is the variance. For our purposes, not as meaningful, but when you hear about variability, it sometimes gets confused with variance. Really what we're talking about is the standard deviation, is the measure of spread. So our last step is to take the square root of 11. Square root of 11, let's take a look at what this would give us. Maybe you can do this in your head. I cannot. I end up getting standard deviation is 3.32. So in this course, the idea is to be able to interpret what that means. But it is also important to be able to get access to that information using the tools you have at hand. So the question comes up, what does this number really mean? The standard deviation was calculated to be 3.32. That means that in this brand, on average, each one of these is a little over 3 away from the mean. You recall in brand Y, all of them were the same at 3 months. So the variability or standard deviation would be 0. But here we're saying on average you're going to be about 3 away from the mean. So we have now calculated the descriptive statistics or measures of central tendency, mean, median, and mode, and also the standard deviation. I hope you tried it for brand Z. If you went through and did the same calculations for brand Z, especially for the standard deviation, you would have found it to be 1. So, comparing these again, look at brand X, Y, and Z. The averages were all 3. The medians were all 3. The mode was 0 in brand X, 3 in Y, and then there was a tie between 2 and 4 in brand Z. The standard deviation we found through our calculation earlier for brand X was 3.32. That's saying on average, each one of the observations in this sample is a little over 3 away from the mean. Brand Y, there was no difference from the mean. And finally, brand Z, it came out to be 1. So, which one has the least variability? Definitely brand Y. Which was the second one that has the least variability? Brand Z, because it was only 1. And finally, brand X had the most variability. So if I had to make a choice based on this small sample, I would probably go with brand Y, with a close second being brand Z. And brand X I would probably skip because it just doesn't have that consistency or reliability.